Growth models of Kaldor and Pasinetti. First of all, we'll take up Kaldor's growth model. Kaldor's model considers origin of technical progress as endogenous. It provides a framework that relates technical progress to capital formation. The model is based on Keynesian technique of analysis and dynamic approach of Herod in regarding rates of change in income and capital as the dependent variables of the system. First, we shall take up the assumptions of the model. In a growing economy, the level of output is at any point of time is limited by the availability of resources and not by effective demand. In other words, it assumes full employment in the strictly Keynesian sense, in which short-run aggregate supply curve is inelastic. Secondly, technical progress depends on rate of capital formation and technical inventions. 3. Variables in the model: income, capital, profit, wages, savings and investments are expressed in real terms. In other words, they are measured at constant prices. Fourthly, investment is partly a function of change in output and partly of change in the rate of profit on capital in the previous period. Monetary policy is assumed to be passive. Rate of interests follow rate of profit. It is assumed that there is no effect of change in the share of profit and wages and of change in the rate of profit on capital on the choice of technique. These are the assumptions of the model. Framework of the model. There are 3 equations which we shall be discussing. One is the saving function. Equation number 1, saving function. Saving at period t is equal to alpha pt plus beta yt minus pt, where pt stands for profit in period t, y minus pt stands for the share of wages in period t or the share of workers in total income in period t, whereas st is the combined saving. Alpha is the propensity to save of the capitalists, beta is the propensity to save of the wage earners, where 1 is greater than alpha, which is greater than beta, which is greater than or equal to 0, which means that the propensity to save of the capitalists is greater than the propensity to save of the workers or laborers. The second equation is the investment function, where kt is equal to alpha dash yt minus 1 plus beta dash within bracket pt minus 1 divided by kt minus 1 multiplied by. This is the capital stock at period t. Kt stands for the capital stock during period t. Yt minus 1 is the income in previous period. Pt minus 1 upon kt minus 1 is the ratio of profit to capital in previous period. Alpha dash and beta dash are the proportions. Alpha dash is the proportion of previous period's income which is turned into capital. Beta dash is the proportion of rate of profit. This is equation 2. Now equation 3 is it is equal to kt plus 1 minus kt. That is, it is equal to change in capital, which is written as equation 3. So investment, or the equation 3, implies that investment in period t is equal to the growth rate of output and is related to changes in the rate of profit from previous period. Equation 1, 2, 3 provide the mechanism underlying saving and investment. Saving function shows savings are determined by propensity to save out of profit and wages. Investment function shows investment is determined by increase in output and change in the rate of profit. Now we come to the equation 4. Equation 4 is the equation of technical progress, which is written as yt plus 1 minus yt divided by yt is equal to alpha 2 dash plus beta 2 dash multiplied by I upon kt, where alpha 2 dash is greater than 0 and beta 2 dash lies between 1 and 0. The left hand side is the rate of growth of income or productivity. So it means productivity is an increasing function of investment as a ratio of total capital stock plus change in technology or improvement in technology. Or in other words, increase in productivity depends upon capital formation and technical progress, where beta 2 is per capita capital and alpha 2 stands for technical progress. Taking into consideration these equations or these relationships, we will discuss the operation of the model under two situations. When the population, or for that matter working population, is constant. B, when the population is expanding. Given these conditions, if we start from an arbitrary point of time t is equal to 1, existing stock of capital K1 can be treated as datum, which is inherited from past. Y0 or income of the previous period and K0 capital stock in the previous period are also given. Y1 can be, or the income during the current period can be taken as the given income which the fully employed labor force produces with capital stock K1. Capital stock K1 satisfies the following condition. K1 upon Y0 is equal to alpha dash plus beta dash multiplied by P0 upon K0. This is equation 5. We have derived this from this has been derived from equation 2 simply by dividing the two sides by Y0. Since K1 and K0 and Y0 are given, in equation 3 can be rewritten as I1 upon Y1, which is equal to Y1 minus Y0 divided by Y0 times K1 upon Y1 plus beta dash P1 upon K1 minus P0 upon K0, equation 6. Equation 6 shows that the rate of investment in period 1 as a proportion of income of that period equals the rate of growth of income over previous period multiplied by capital output ratio plus it is a proportion of change in rate of profit over the previous period. Equation 1 of saving function can be written as equation 8 by dividing both the sides by income of the current period. This is the saving function. The two equations 7 and 8 jointly determine both the distribution of income between profit and wages and the proportion of income saved and invested at point t is equal to 1 or during period. Given a particular distribution of income, the level of profit acts as an equilibrating mechanism between saving and investment, or in other words, variation in level of profit brings about equality between investment and saving. That changes in level of profit lead to changes in investment and consequently bring about equality of saving and investment. This can be explained with the help of diagram. On the horizontal axis, we have rate of profit or P upon Y. On the vertical axis, we are writing I upon Y, that investment as a proportion of income and saving as a proportion of income. The two curves are given here, investment function and saving function. The two curves are intersecting at point E. To the left of point E, investment is more than saving. This leads to increase in rate of profit and further increase in investment. And this goes on till saving and investment are equal. To the right of point E, investment is less than saving, which means the rate of profit can be increased by reducing the investment. So, rate of profit actually brings about equality in saving and investment. Equation 7 and 8 determine both the distribution of income between profit and wages and proportion of income saved and invested. Given a particular distribution of income, level of profit acts as a mechanism of equilibrating saving and investment. Given a particular distribution of income, level of profit acts as a mechanism which brings about equality between saving and investment. Level of profit acts in such a way to induce that rate of investment is just equal to rate of saving at that particular distribution of income. This can be explained with the help of figure 1. On horizontal axis, we have the level of profit or rate of profit. On the vertical axis, we have saving and investment as a ratio of income. Line SS dash is the saving function and line II dash is the investment function. Now, stability requires that alpha minus beta is greater than beta dash yt upon kt. In simple words, it means the slope of the saving function is greater than the slope of the investment function. Alpha minus beta is the slope of the saving function and beta yt upon kt is the slope of the investment function. This means that the growth rate of saving should be greater than that of investment for the stability of the equilibrium. But this condition is only a necessary condition. The sufficient condition for the stability is the sufficient condition for stable and steady growth are the following. Pt is less than y minus w minimum, equation 10. Pt upon yt is greater than m. Equation 10 requires that the level of profit should not exceed income minus minimum wages. Equation 10 means that the rate of profit should be greater than or equal to a minimum rate of profit so that it induces capitalists to invest in future. Equation 9, 10 and 11 imply that equilibrium brought about by the equality of saving and investment. However, the steady growth path would depend on the technical progress function, which is given below. Assuming these three conditions are satisfied, the technical progress function ensures the growth of income and capital from period T1 onwards and the gradual shift of the economy from a short-run equilibrium to a long-run equilibrium of steady growth. This is illustrated in figure 3. On the horizontal axis, we have the rate of growth of capital. On the vertical axis, we have the rate of growth of income. The 45-degree line shows all those points where the two are equal. Tt is the technical progress function. At point G, we have rate of growth of capital equal to rate of growth of income. This is the point of steady growth of income. Suppose that the initial rate of investment at T1 is equal to I1 upon K1. Then rate of growth of capital is less than rate of growth of income. In order to equate rate of growth of capital to rate of growth of income, investment will increase in period 2 to I2 upon K2, which is equal to G1. But because of increase in investment, the income growth has further increased to G2. Similarly, in the next period, the investment will further increase. And the new rate of capital formation will be I3 upon K3. The income will be G3. Now, when investment is increasing, our capital formation, rate of capital formation is increasing, the output or rate of growth of output is also increasing. Indirectly, this is further strengthened by the improvement in the rate of profit. The process will go on till point G. Here, the rate of growth of capital formation is equal to rate of growth of income. To the left, to the right of this, what we find? Rate of growth of capital is more than rate of growth of income. Consequently, I upon KT will decrease in future and come back to G. So point G is the point where rate of growth of income is equal to rate of growth of capital. This is the point where we have steady growth. The long run equilibrium rate of growth of income and capital is independent of the saving and investment function. It depends only on the technical progress function, which is given by equation 12. G is equal to alpha 2 1 minus beta 2 dash. This can be verified from equation 4. When rate of growth of capital is equal to rate of growth of income, then what we find, this equation is satisfied. Equation 12 is the equilibrium rate of growth of productivity, that particular rate of growth of productivity which makes growth rate of income and capital equal. Therefore, it can be concluded that technical progress function is essential for establishing dynamic equilibrium between saving and investment and moving the economy towards the steady growth path. Here, we have discussed how the economy will be moving towards steady growth when the population, for that matter working population, is constant. Now I come to the second part of the growth model, expanding population. To take into account expansion of population, Kaldor, like Malthus, assumes that population growth is a function of rate of increase of the means of subsistence, which is assumed to be equal to the rate of increase in total production. Kaldor makes 2 points. For a given fertility rate, the rate of growth of population cannot exceed certain maximum regardless of how fast is the growth of income. Secondly, the rate of population growth will rise only moderately as a function of the rate of growth of income, and for some interval of the latter before the maximum is reached. Given these 2 points made by Kaldor, we use certain symbols. L1 stands for rate of growth of population at point T. GT stands for rate of growth of income at point T. Lambda is the maximum rate of growth of population. Kaldor expresses the relationship between population growth and growth rate of income algebraically like this. LT is equal to GT. If GT, the growth rate of income, is less than maximum rate of growth of population, and IT, the growth rate of population, is less than maximum rate of growth of population, rate of growth of population and income will continue to increase till the growth rate of population equals lambda. Therefore, in the long run, equilibrium, population must grow at its maximum rate, which is indicated by the horizontal section of the line in figure. Now, in figure on horizontal axis, we are showing growth rate of income. On vertical axis, we have the growth rate of population. Curve OM is the growth rate of income. Curve PL lambda is the curve showing the growth rate of population. As the growth rate of income increases, growth rate of population also increases till it approaches lambda. At point E, the growth rate of income is equal to maximum growth rate of population. As the growth rate of income increases, growth rate of population also rises till it becomes equal to lambda. As growth of income reaches point E, GT exceeds IT, that the growth of income exceeds IT. In the long run, population will grow at its maximum rate. This assumes that the shape and position of the technical progress function given by alpha dash 2 dash and beta 2 dash in equation 4 of technical progress function is not affected by the changes in population. This implies that there are constant returns to scale. In other words, an increase in numbers given the amount of capital per head leaves output per head unaffected. This assumption may be valid for a developed economy. This assumption may not be valid for an underdeveloped economy or overpopulated economy. This assumption may be valid in the case of a relatively underpopulated country. In overpopulated countries, scarcity of capital and land will cause diminishing returns. In underdeveloped countries, there is low capacity to absorb technical change because of scarcity of land and capital. Due to this, the technical progress function will be lowered with the increase in growth rate of population. See figure. In figure, on horizontal axis we have rate of increase in capital, and on vertical axis we have the rate of increase in income. 45-degree line shows the two are equal at each point. TT dash is the technical progress function. In an overpopulated country, a technical progress function will cut the capital axis positively at point T in figure 5. This means to maintain output per head at a constant level, a certain percentage growth in capital per head will be required. We therefore have 2 points of intersection with 45-degree line at P dash and P. TT dash is intersecting 45-degree line at 2 points, P dash and P. Point P is the stable equilibrium point, and point P dash is the unstable equilibrium. Points, if the economy is to the left of, slightly to the left of point P, investment will increase, output per head will increase, and consequently we will move towards point P. On the other hand, if the economy is to the right of P, the reverse will happen. But at point P dash, if the economy is below point P dash, if the economy is in a position which is to the left of P dash, the rate of growth of income and capital will steadily diminish until the growth of income and capital come to complete standstill. In this situation, it is even possible that the position of the technical progress function TT dash curve is below the diagonal line as shown by T1 T dash in figure 5. In this case, no long run equilibrium is attainable. This may give rise to a situation of stagnation in the economy. Whether an expanding population will be consistent with equilibrium growth of or not will primarily depend upon the relative magnitude of two factors: maximum growth rate of population and the rate of technical progress, which causes certain percentage increase in productivity when both population and capital per head are held constant. Concluding remarks. Kaldor's model of economic growth is dynamic in nature, and an important feature of Kaldor's model is introduction of technical progress function. Kaldor considers savings are interdependent in the growth process. The expanding population version of the Kaldor's growth model represents the real world situation and is applicable to the underdeveloped countries, where rapid growth of population is an important feature. In these words, Kaldor's growth model is more realistic than earlier neoclassical models, as it is applicable to both developed and underdeveloped countries. Pasinetti model. Pasinetti postulates a simple relationship between rate of profit, the income distribution, and rate of economic growth. The model has made correction in the Kaldor's theory of distribution and points out that in any type of society, when an individual saves a part of his income, he must also be allowed to own it. Otherwise, it would not be possible for him to save. This implies that the stock of capital which exists in the system is owned by by those who save, irrespective of the fact whether they are capitalists or workers. The workers may be saving, owning these assets indirectly in the form that they have given loans to the capitalists. Thus, total profit may be divided into two parts: profits accruing to the capitalists and profits accruing to the workers. Kaldor's theory did not take into account profits accruing to the workers. Pasinetti reformulated the theory of distribution, and Pasinetti reformulated the model to eliminate the confusion regarding the two different concepts of distribution of income. Distribution of income between profit and wages, and distribution of income between capitalists and workers. These two concepts of income distribution will only coincide in a particular case when workers do not save, that there is no saving out of wages. The model. Y is total income. It is divided between wages and profit. Aggregate saving S is the saving of the workers and saving of the capitalists. Saving propensities of the two are given. Total profit P is equal to profits of the capitalists and profits of the workers. These can be expressed as equation 1, 2, 3 and 4. Saving function of the worker and capitalists is defined as saving of the worker SW is proportional to W plus PW. Equation 5. Saving function of the capitalist is shown by the equation 6, where small sw and small sc is the propensity to save of the workers and propensity to save of the capitalists. The condition under which the system will remain in a dynamic equilibrium is saving investment equality, I is equal to S. Substituting the saving function into the saving investment equality, the equilibrium condition becomes I is equal to SW multiplied by W plus PW plus SC PC is equal. This is equation 7. From equation 7, we obtain equation 8 and equation 9. These equation 8 and 9 have been obtained by manipulating equation 7 and then dividing both the sides by y in order to get equation 8 and by k in order to get equation 9. Equation 8 expresses the distribution of income between capitalists and workers, but the distribution of income between profit and wages is something different. And to obtain it, we need to add the share of workers in profit, which is PW upon Y to both sides of equation 8. Equation 9 represents the ratio of profit, capitalist profit to total capital. In order to obtain the ratio of total profit to total capital, we must add PW upon K to both sides of equation 9. So, putting these values in equation 8 and 9 on both the sides, we get equation 10 and 11. Equation 10 shows the total profit, the share of total profit in income is equal to PC upon Y plus PW upon Y. And the rate of profit is equal to PC upon K plus PW upon K. So, we already know that PC upon K from equation 9. Writing KW for the amount of capital that workers are on indirectly through loans to the capitalist or for the interest rate on these loans, we obtain P upon K as equation 12. This is simply equation 11 where we have added R times KW upon K to the right hand side. Now we require an expression for KW upon K. That is to say, share of workers in total capital. This can be found out by the given equation 13, where KW upon K is equal to SW times SC divided by SC minus SW multiplied by Y upon I minus SW upon SC minus SW. Substituting this equation, equation 13 into equation 12, we get equation 14. And manipulating it, we get the profit rate, where profit rate is expressed as function of ratio of investment capital, ratio of income and capital, ratio of income and investment, and saving and investment propensities, and the rate of interest. Similarly, we can find out equation 15 from equation 10. Now, as you know, equation 8 showed the distribution of income between capitalists and workers. Equation 15 represents the distribution of income between wages and profit. So Pasinetti clears the distinction between distribution of income between profits and wages and distribution of income between capitalists and workers. Equation 15 represents the distribution of income between wages and profit, whereas equation 8 represented the distribution of income between profits and wages. Now, given these, we come to rate and share of profit in relation to rate of growth of income. In the long run equilibrium model, it is obvious to assume that the rate of interest is equal to rate of profit. If we formulate such a hypothesis and substitute P upon K for R in equation 14, P upon K is actually the rate of profit, and we are assuming that the rate of profit is equal to rate of interest in the long run. So we get, putting this in equation 14, we get this equation, P upon K within bracket, these are given here, is equal to this. And solving this, we get the equation 16, which shows that rate of profit is related to ratio of investment to capital and the propensity to save of the capitalist. Similarly, from equation 15, we get Py is equal to 1 upon Sc times I upon Y. That distribution of income is related to propensity to save of the capitalists. Now, equation 16 and 17 gives most striking results of Pasinetti model. It shows that propensity to save of the workers does not influence the income distribution between profit and wages. Further, it has no impact on rate of profit. The model is based on institutional principle that profits are distributed in proportion to the ownership of capital. This means, given the rate of profit, everyone gets the share in profit according to the amount of ownership of capital. This implies that in the long run, profits are distributed in proportion to the amount of saving contributed by both categories, that is to say workers and the capitalists. In other words, profits are proportional to saving, and the ratio of profit to saving are same for both the workers and capitalists. Thus we get equation 18, which is PW upon SW, which is equal to PC upon SC. That is proportion of profit received by, as proportion of profit, ratio of profit to the savings, and ratio of profit to savings in the case of both capitalists and workers are same. In order to determine the actual value of the ratio of profit to saving for the whole system, we substitute the saving function of the capitalists and workers in this equation. So we get the equation PW upon the saving function of the workers is equal to PC upon the saving function of the capitalists, which can also be written as saving function of the workers is equal to saving function of the capitalist, equation 19. Equation 19 states that in the long run, when workers save and receive an amount of profit PW such as to make total saving exactly equal to the amount that the capitalist would have saved out of workers' profit, if these profits remained with the capitalist. In other words, worker will always receive in the long run an amount of profit proportional to their saving, irrespective of the rate of profit, whatever the rate of profit may be. Hence, the rate of profit is indeterminate on the part of workers. However, there is a direct relationship between saving and profit in the case of capitalists, since all their savings are invested or all their savings come out of the profit. Therefore, for any given propensity to save of capitalists, there is only one proportionality relationship between profit and saving, which makes PC upon SC times PC equal to PC upon SC according to Pasinetti. This proportionality relationship can be nothing but the propensity to save of the capitalists, small sc, which will therefore determine the ratio of profit to savings for all the saving groups, and consequently also the income distribution between profit and wages and the rate of interest for the whole system. So, according to Pasinetti's model, the propensity to save of the capitalist determines the ratio of profit to saving for all saving groups and the income distribution between profit and wages and the rate of interest for the whole system. Pasinetti model shows that there exists a distribution of income between profit and wages which keeps the system in the long run equilibrium. In order to maintain full employment over time, a specific amount of investment has to be undertaken, which is uniquely and exogenously determined by technology and population growth. In this case, the equilibrium rate of profit is determined by the natural rate of growth divided by the capitalist's propensity to save. This is given by the following equation. This is P upon K N is equal to SC. It is important to note that the equilibrium rate of profit is independent of other variables of the model. The rate of profit is determined by equation 20, keeps the system on the dynamic path of full employment in a system where full employment investment are actually carried out and prices are flexible with respect to wages. The only condition necessary for stability is that propensity to save of the capitalist is greater than 0. There are two implications of the Pasinetti model. First, two implications of the Pasinetti model. First, the rate of profit and income distribution between profit and wages are determined independently of the worker's propensity to save. Second, the proportion that profits must bear to saving in the whole system is given by the capitalist's saving propensity too. The worker's decision to save are irrelevant. The share of total profit according to workers, the share of total profit accruing to workers, PW, is predetermined and the workers cannot influence it. Here we have discussed the main features of Pasinetti model, and this is actually an improvement over the Kaldor's model because Pasinetti has included another group which receives profit, whereas in Kaldor's model only capitalists were receiving profit.